Good morning, students. Last class we have learnt about a combination of resistors. Along with that, how we did the Ohm's law experiment also I have shown, and I have shown the separate instrument of voltmeter, ammeter and resistors, right. I hope you enjoyed watching that and you experienced that how we can proceed with an experiment, right. When you come back, we will do the same experiment in our lab. Today, as a follow-up of day, we are going to learn numericals based on combination of resistor. Because we already, in the beginning itself, we have learnt that this lesson is mainly based on numerical oriented. So, combination of resistor is the important part of the numerical in this. So, we shall recall the formula. When we connect all resistors in series, then the effective resistor will be, resistance of the resistors will be R1 plus R2 plus R3 and so on it can go. Likewise, parallel, when we connect all resistors in parallel, then the effective resistance will be 1 by Rp is equal to 1 by R1 plus 1 by R2 and so on. So, these two are the important formula we are going to employ in this. And students, this is the time to pass your video. Please go on, take your textbook and writing material and your notebook also. Because in the complete lesson, we are going to work out the problem today. So, it is time to pass the video here and go on, take your textbook, notebook and writing material. Okay. I hope that you all brought your things, right. So, we are going with the, now you go to page number 213 in your NCERT textbook and the in-text question of 1 and 2. In-text question means the questions given in the box in the page number 213, right. The first part of the questions goes with, you have to draw a circuit with a battery of 2 volt cell of 3 and a plug key and a resistance of 5 ohm, 8 ohm and 12 ohm all connected in series, right. The same statement now we are going to do it in a circuit form. See, they said that 2 volt each, 3 cells, this is one cell, this is another cell, this is another cell. So, we have constructed a 2 volt cell 3 in a series along with the plug key. It can be also known as switch of the instrument. Then we have connected in series a 5 ohm resistor, 8 ohm resistor and a 12 ohm resistor and we have closed this circuit. So, the first part we have constructed a circuit diagram as per the information given. Now, the same, this is question number 1. In the question number 2, they said that redraw the same circuit to change, that you have to include how we have to measure the current and also we have to measure the potential difference across 12 ohm resistor. What is the instrument used to measure current? Yeah, we all know that, you are right, it is ammeter. So, in our circuit we have to include ammeter. And what is the instrument which is used to measure the potential difference? Yeah, it is voltmeter. So, you have to include the voltmeter, but the question says that you have to find the potential drop across 12 ohm resistor, right. So, now redraw the circuit like the same. Now, your battery consists of 3 cells of each 2 volt, a plug key and a ammeter and 3 resistors, and we are going to measure the potential difference using voltmeter across this 12 ohm. Now, you have constructed the reconstructed the complete circuit diagram and represented. See, once again I am saying, they ask you to include an instrument used current. So, we have included ammeter and they ask us to find out the potential difference across 12 ohm. So, we have included a voltmeter here. So, the same circuit. In this, we are going to find out two subdivisions of problem. They said that what is the current flowing in the circuit and the next one is potential difference across what is 12 ohm. So, to find out what is the current in that, we know the formula V is equal to IR by Ohm's law, right. So, in this V, we know that each cell is having a 2 volt, we are having 3 cells. So, 2 volt into 3, we have 6 volt. And what is R? We have 3 different resistors here. And remember, all these resistors are connected in series. To find out the effective resistance of that, go with the formula of Rs is equal to R1 plus R2 plus R3. So 5 ohm plus 8 ohm plus 12 ohm, altogether 25 ohm. So effective resistance of this circuit is 25 ohm. Now use our Ohm's law. V is equal to IR. From this you can rearrange the formula as I is equal to V by R. V is 6 volt, R is 25 ohms. Then when we divide this and we will find out the formula, it is 0.24 ampere. So current is measured in the unit of ampere. We have find out what is the total current flowing in the circuit. I is equal to 0.24 ampere. Now the next part of the question says what is the potential difference across this voltmeter when we connect across 12 ohm. So we should find out what is the potential difference V now. The same formula V is equal to IR. Now we found out what is the total current in the circuit. It is 0.24 ampere into the resistance value 12. So when you multiply you will get 2.88 volt. So from the construction of a circuit, we have rearranged the circuit and finally we computed what is the value of current in the circuit and the potential difference across 12 ohm. Students, the same sum once again 2 or 3 times repeat in your notebook also. Now we will move on to page number 215 in your textbook. It is example 12.9 and it is a very important type of a problem. This type of a circuit will be, this is a very simple type. What I am discussing today is a simple type of a circuit. Like this combination of resistors will be repeatedly asked in our board exam. So in the exam point of view, it is a very important question for us. See, the question says us it is connected, the same circuit diagram is given there in your textbook also. Circuit is given where the resistors R1 and R2 are parallelly connected. An ammeter is connected with a series to them and the resistance R3, R4, R5 are again connected and they have connected with a plug key and the circuit is closed now. Now we are given with the value of R1 and R2. R1 is 10 ohm, R2 is 40 ohms, R3 is 30 ohms, R4 is 20 ohm and R5 is 60 ohm. From this question, now we can understand the first part. See, here one parallel type of circuits resistors are connected. Here also parallelly 3 resistors are connected. So you can group like this. R1 and R2 combined together we can call that resistors parallel set 1. And R3, R4, R5 we can say it is resistors parallel set 2, right. So I am representing here as RP1 and RP2. Now I am going to redraw my circuit by replacing R1, R2 by RP1 and R3, R4, R5 by RP2. See the redrawn circuit, see the same battery, same key, ammeter, everything is given. Instead of the combination of resistor here, I have placed RP1. Instead of combination of 3 resistors here, I have placed RP2. See, now when compared to this diagram is very simple and you are able to understand easily. Now you can conclude that RP1 and RP2 are connected in series, right. From this one and we have simplified our diagram and we have concluded RP1 and RP2 are connected in series, right. So now we have to find out what is our RP1 value and RP2 value. So now we will go for the workout part of that. So 1 by RP1 is equal to 1 by R1 plus 1 by R2, substitute the value 1 by 10 plus 1 by 40, cross multiply 1 by RP1 is equal to 50 by 400. So now we want to find out what is RP1 only. So RP1 is nothing but inverse of that 400 by 50. So it is 8 ohms. Likewise this part, second part also 1 by RP2 which is equal to 1 by R3 plus 1 by R4 plus 1 by R5. Now you substitute again the known values of R3, R4 and R5, 1 by 30 plus 1 by 20 plus 1 by 60. When you simplify you will get 6 by 60, then RP2 is equal to 60 by 6 which is equal to 10 ohms. Now from this part we have find out what is RP1 and RP2. How we have connected RP1 and RP2 here? Both are in series. So RS is equal to RP1 plus RP2. So addition of these two values 8 ohm plus 10 ohm gives 18 ohm. So, from this circuit we have computed the value what is the effective resistance given when 5 different resistors are given. So, we have simplified this circuit diagram into two parts, that is RP1 and RP2. We have find out individually what is RP1 and RP2. Finally, we have by using this diagram R effective is RS. So, RP1 plus RP2 we have concluded the value with 18 ohms. Children, now turn your book page number 216 in text question 4. It is somewhat a tricky question. They said that what is the given value of the resistance? Given is 2 ohm, 3 ohm and 6 ohm. They have given the value of the 3 resistors and they ask you to find out what is the R effective, that is effective resistance of the circuit will be 4 ohm when, and they have asked you effective resistance will be 1 ohm when. So, what is this when means? It is nothing but how you are going to connect that resistors in your circuit. So, now we know two methodology of connection, right? We can connect the resistors in series, also parallel, as well as we can combine together one is in series, one series with the parallel of 2 or 2 series with the parallel of 1. See, we can connect this method. This is one method. Either I can connect, see these two are in series, this is a parallel. So, any type, any combination of methods I can go on. So, here like a trial and error method only. Children, this is, there is no exact method, you have to go like this. This is simply a trial and error method, and by this value I am going to relate these values. We know that two statement based on R effective in series and R effective in parallel, right? When I want to connect a series, it should give always the maximum value. What is the maximum value of this effective will be when I connect everything in series? You may ask, ma'am, why don't we go for a direct all in series? See, check 2 plus 3 plus 6, 5 plus 6, 11 ohm, maximum value 11 ohms, which is not there in that. So, and we can go with that. Now, I am going for a combination purpose. Now you go for a parallel also, 1 by 2 plus 1 by 3 plus 1 by 6. Somewhat it is a sound related to our R effective, right? Now we will work out. First the 3 resistors, I am going to consider one pattern that R1, the first resistor is series with the parallel of R2 and R3. That is nothing but my R1 is going to be series with the parallel combination of R2 and R3. Now I am going to find out what is the effective resistance between A and B. So what is RP here? 1 by R2 plus 1 by R3. That is nothing but 1 by 3 plus 1 by 6, which I simplify, I will get 1 by 2, which implies my RP is 2 ohm. So this part is totally 2 ohm. So I can redraw my circuit like this. So my RP value is 2 ohm. Already I have a 2 ohm resistors in series. So when I add these two, RS is equal to R1 plus RP, which is equal to 2 plus 2, 4 ohms. I got the value of 4 ohm, which is given here. So I will get my R effective 4 ohm when I connect one resistor and the parallel of the other two resistor. That is R1 is series with the parallel combination of R2 and R3, right? And when we discussed the maximum value is not suitable here. In the minimum value is parallelly connected, we will get the minimum value. So compared to 4, 1 is a very less value, minimum value, right? It will be sounds good when we connect everything in a parallel connection. See, in between A and B I have connected R1, R2, R3, everything in a parallel. So 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by 2 plus 1 by 3 plus 1 by 6. So all together I will get 6 by 6, which is nothing but 1 by 1. So my resistors are connected in parallel, then I will get the effective resistor as 1 ohm. So what is given here? So when we get R effective, everything is connected in parallel, then we will get the minimum value, and we get that intermediate value when go for a combination of series and parallel resistance, right? Children, if when these type of questions is asked to you, it is you have to decide, either you have to go for a whether the given value is a maximum, then simply you go with the RS is equal to R1 plus R2, what is the number of resistance given, and the minimum value, very less value is given, then you can go for a parallel. If there is any intermediate value is given like this, then only you have to go and think of this type of a combination by practice, and you will be able to quickly compute the values and you can resolve these type of problems very easily. So children, today we have discussed one example and a few questions in your in-text book. From your in-text, I have referred the page number also. While I am teaching the class itself, you might have started to work out. After seeing this video, again open your textbook, one more time you work out. When you become very familiar, please do all this workout. The rest of the questions of your in-text in your classwork notebook. Thank you children. Catch you in the next class.